In example I, we can split this up and we can say that we're looking for a limit as x goes to 0 of sine x, and we can do that separately from sine x over x. Okay, so when we evaluate this limit, the limit as sine x goes to 0 is 0. Sine x over x, again, is an identity. We kind of identified that one already, and that's equal to 1. 0 times 1 equals 0. So the limit of that is equal to 0. This one here, L'Hopital's would deal with this one really easily. We don't actually have an identity for sine 2x over x, although we can, after this, we can kind of make one. It is going to be equal to 2, so we can generalize that to, if it's sine ax over x, it will be equal to a. But we'll do a bit of algebra here to show that we can prove this. So we're going to use our identity, double angle identity, and convert this to sine 2x into 2 sine x cos x over x. So when we do this, we can, our limit laws let us take out that coefficient, and it allows us to deal with sine x over x separately from cos x. We can apply the limits independently to that. We've already established what that is. We know that that's going to be equal to 2 times. That's going to be equal to 1 when the limit as x goes to 0. And cosine of 0 is equal to 1. Okay, so this cosine x, as we plug in 0, we get 1. So then the limit of this is 2 times 1 times 1. The limit is equal to 2. So we could make the same argument if there's an a in there and say that this would just be equal to then a. So that is a nice identity to know. If you recognize it, we can apply that identity.